Hello, this is Josab Ryan V. Padel, a stressed civil engineering student from Eastern Visayas State University, first year section A. One of the topics I need to learn under this course is graphing ellipses. So join me as I answer these three questions that will help us master how to graph an ellipse.
First problem. Graph the ellipse of x squared over 25 plus y squared over 16 equals to 1. First, we will get the center of the ellipse. By doing that, let's take note of the standard formula. X minus h quantity squared over a squared plus y minus k quantity squared over b squared is equals to 1. Since there is no values of h and k, the center would be at the origin. So C, 0, 0. And now we will determine the a squared and b squared of the equation. Since 25 here is the bigger number, that would be our a squared. So a squared is equals to 25. Thus, a is equals to 5. And the b squared would be equals to 16. Thus, b is equals to positive and negative 4. Let's find the value of c. So c would be equals to the square root of a squared minus b squared. Since we already have the value of a squared and b squared, we can get the value of c. So c is equals to positive and negative 3. And now let's graph. Now that we have found out a, b, and c, we can now graph the ellipse. Starting with the center at the origin, since the value of a, which is 5, is below the variable x, we will move 5 units parallel to the x-axis from the center. So b is equals to 4. We will move 4 units upward and downward from the origin or from the center. We can now then graph the ellipse. Since we have now the value of c, which is positive and negative 3, we can now plot the foci of the ellipse. We will just move 3 units from the center horizontally. And now we can get our focus. Now that we have plotted the vertices and co-vertices of the ellipse, let's try to find naman the lateral recta, which can be found through this formula. Positive negative b squared over a plus minus c. So, positive negative 16 over 5, comma, positive negative 3. So, positive 16 over 5 and positive 3, which would be right up here. Positive 16 over 5, negative 3. Negative 16 over 5, negative 3. And negative 16 over 5 and positive 3. So this point would be our R1, This is L1, R2, and L2. Let's find naman the directrix of the ellipse, which can be solved by k plus minus a squared over c. Yes, this should be h instead of k because our ellipse is lying horizontally and not vertically. With the given values k, h at 0, a squared is 25 and c is 3, we can get our directrix, which is 25 over 3, positive and negative, or in decimal, which is 8.3. Now we can plot our directrix. So 8.3 units from the center, which should be right here, and there. This will be our D1 and this is our D2. And that's it. That's how you graph the ellipse of x squared over 25 plus y squared over 16 equals to 1. Now let's move on to our second problem. 4 multiplied to x plus 2 quantity squared plus y minus 1 quantity squared all over 4 equals to 1. So what we'll do here is to drag this 4 coefficient into the denominator. By doing that, we will rewrite the 4, which is 4 is equals to 1 over 1/4. Now, the denominator of x plus 2 quantity squared will be 1/4. So let's rewrite the standard equation of this ellipse. X plus 2 quantity squared over 1/4 plus y minus 1 quantity squared over 4 equals to 1. You've noticed that we have now our values of h and k. So, seeing this standard equation, h would be negative 2 and k would be positive 1. So our center would be negative 2 and positive 1. You've noticed that the bigger denominator is below the y variable. So that would be our a squared is 4. Thus, our a is equals to 2, positive and negative 2. And for our b squared, it would be 1/4. Thus, b is equals to the square root of 1/4, which is 1/2. Now that we have the values of a squared and b squared, we can get now the c, which can be derived by the expression square root of a squared minus b squared, which would be square root of 4 minus 1/4. Now we get our calculator. So the square root of, let's try to input the values, 4 minus 1/4, and that is square root of 15 over 2. Now that we have determined the value of A, B, and C, let's find the vertices, co-vertices, and foci of the ellipse. So this is how will you get the vertices of this ellipse. So H, comma, K plus minus A. We will add the A value since the A is below the value of K. Since our H is negative 2 and our K is positive 1, we will just write it down. So negative 2, comma, 1 plus minus 2. So our vertex 1 will be negative 2, comma 3, and our vertex 2 is negative 2, negative 1. For our co-vertices, we will just the value of B to the H and comma K. So B is negative 2 plus minus 1 half, comma, positive 1. Then we will just solve it. Our co-vertex 1 will be negative 3 halves, comma 1. And for our co-vertices 2 will be negative 5 halves, comma 1. Now we will find the focus of the ellipse since we have our values of vertex, our vertices and co-vertices. So our focus will be determined by, since the ellipse seems to be lying vertically, we will add this value of C on the K. So negative 1 or negative 2, comma 1 plus minus square root of 15 over 2. So that will be our focus of the ellipse. We will just simplify this later. Negative 2, 1 plus square root of 15 over 2, and f of 2, negative 2, 1 minus square root of 15 over 2. And now we will graph the ellipse. Given our center at negative 2, positive 1, so it should be right here. For our vertices, it will be negative 2 and positive 3, and negative 2 and negative 1. So it will be right here and right here. For our co-vertices, it will be right here and negative 5 halves, comma 1. It will be somewhere between 2 and 3 here. Let's just connect these points, making it an elliptical shape. Focus, we will just plot these 2 points. I'll just input that on my calculator, and yeah, just watch me. Just speed this up a little bit. And now we have our foci, and here and here. Now that we have plotted these 7 points, we will find naman the lateral recta or the latus rectum that which can be solved by this. Just follow these steps. The L's and R's of the ellipse will be represented as h plus minus b squared over a, comma, k plus minus c. With that general equation, you can derive for 4 equations, and then you will have 4 distinguished points, and that would be your latus rectum, your 2 latus rectum. So here I'm now doing the equation for L sub 2, which is h minus b squared over a, comma, k minus c. The R would be h plus b squared over a, comma, k plus c. The R sub 2 would be h plus b squared over a, and then k minus c. With that, you have 4 points, as I said. So just watch me as I answer these 4 equations. You can derive for this. L sub 1 is negative 2.125, comma, 2.936. And then just answer the 3 other equations. Here you get L2, R1, and R sub 2. So you just plot the points. And here's our points. So after finding the latus rectum of the ellipse, we'll now find the directrix of this ellipse, which we can get by this formula. Y is equals to k plus minus a squared over c, where k is positive 1, a squared is 4, and c is square root of 15 over 2. And now we will just input it to our calculator. So for our first directrix, it would be negative 1.06. And for our second directrix, it would be positive 3.066. So this is how you graph the ellipse of this problem. So for our third problem is written in general form, which is 9x squared plus 126x plus 4y squared minus 32y plus 469 equals to 0. Let's remember this standard equation, which we will have to derive this equation, in general form, to those standard equation. So we will start by grouping the numbers that has the same variable. And then we will transfer this constant to the right side of the equation, which will be negative 469. Now let's factor out from the group the numerical coefficient of each variable that has the exponent power of 2, making it 9 multiplied to the quantity of x squared plus 14x plus 4 multiplied to the quantity of y squared minus 8y equals 469. After that, by completing the square, we will make this binomial inside the parenthesis into a perfect square trinomial. So 9 times x squared plus 14x plus the square of 1/2 of 14. So it will be 49. And then adding 4 multiplied to y squared minus 8y plus 1/2 of negative plus the square of 1/2 of negative 8, which is 16, equals negative 469. And then we add the product of 9 and 49 and the product of 4 and 16. Then we will make this perfect square trinomial into a square binomial, making it 9 times x plus 7 quantity squared. And then we will do the same to the y variable, making it 4 times y minus 4 quantity squared equals to this. So we will just input this into our scientific calculator. So it will be 36. Let's just remember the standard equation of the ellipse, like this. So we will divide both sides of the equation by this coefficient of the binomials, the square of binomials, making it so the 9 will just cancel out, the same with 4 and the same with 36 and 9 times 4, since 9 times 4 is equals to 36, making the equation x plus 7 quantity squared over 4 plus y minus 4 quantity squared over 9 equals to 1. And now we can graph our ellipse since we have our standard equation of the problem. So the h and k is making the center at -7 and +4. Since 9 is the bigger denominator, that would be our a squared. Thus, our a is positive and -3. Our b naman, our b squared would be 4. Thus, b is equals to positive and -2. Since we already have the value of a squared and b squared, we can get for our c, which can be derived by the same expression, square root of a squared minus b squared, making it c is equals to the square root of 9 minus 4. So our c would be positive and negative square root of 5. Now let's proceed to graphing the ellipse. At center -7 and +4, moving 3 units upward and downward and moving 2 units sideward. As I said, because a squared is below the y variable, we will move a units upward and downward. And so we have our vertices. And because naman b squared is below the x variable, we will move b units to the right and to the left. Now we have our co-vertices. Because of that, we can now draw our ellipse just by connecting those 4 points. Just don't mind how ugly this look like. So v1 would be at -7, 7. For our v2, it will be -7, +1. For our b2, it will be -5, 4. For our b1, it will be -9, 4. For our focus, we will move C units upward and downward. So, value of square root of 5 is somewhere in here. That will be where our F1 lies. For our F2, it will be here. Here would be negative 7, comma, square root of 4 plus square root of 5. And here would be still negative 7, 4 minus square root of 5. Our latus rectum, it will just be, the points will just be here, alongside with the focus. L1, L2, then R1 and R2. If you will find these points, just see the other example I've already answered and then answered it. For our directrix, since it is another vertical ellipse, it would still be k plus minus a squared over c, where our k is 4, a squared is 9, and our c is square root of 5. We will just input that on our scientific calculator. So 4 plus 9 over square root of 5 is 8.02. That would be where our D1 lies. For our D2, we will just change the operation sign. So it would be 4 minus 9 over square root of 5. So our D2 lies at negative 0.02. For D2, it would just be here. Just put a line on this. And for our D1, it would be right up here. That is where our D1 lies. And then, you have the ellipse, the graph of the ellipse of this problem. So that is how you graph the ellipse of 9x squared plus 126x plus 4y squared minus 32y plus 469 equals 0.
So that's how you answer those three problems. However, learning doesn't stop right here. So for you to be able to master how to graph ellipses, you will need to practice more. So I'm leaving 2 questions for you, or 2 problems for you to answer. So that's it, guys. Thank you for watching.